Welcome to this module on production, transportation, and erection of prefabricated structures. Myself, Dr. J. Bilbari, working as Associate Professor in the Department of Civil Engineering of K.S.Rangasamy College of Technology. In this video, we will study the step-by-step process for manufacturing the components to assembling the final structures on sites. The contents which are going to look into this video are comparisons of conventional system and prefabricated system, productions of prefabricated system, standardizations, advantages of standardizations, and factors which has been affecting the standardizations. So the comparisons of conventional system and prefabricated system. In conventional system, construction is done entirely on site using raw materials like bricks, concrete, and steel. Whereas in prefabricated system, the components such as beams, columns, slabs, and panels are manufactured in the factory under the controlled conditions and then transported to the site for assembly. The key benefits of the prefabricated systems over the conventional systems are faster constructions, high quality control, less labor requirement on site, reduced material waste, and minimal dependency on the water. The construction time will be the longer duration due to the on-site works, curing periods, and weather dependencies on the conventional systems, whereas in prefabricated systems, the faster constructions as the components are pre-named and only assembled on the on-sites. Whereas in case of the quality control, high quality control in factory conditions ensuring uniformity and precision in prefabricated system, whereas in the conventional system, quality depends on the site conditions and worker skills prone to the inconsistencies. Whereas higher initial cost for manufacturing and transportations in case of prefabricated systems, whereas the general lower initial cost but can rise due to delays and wastages in case of conventional systems. And skilled labors is necessary for your conventional systems, and as in the prefabricated systems, less on-site labor is needed, more factory-based work is there. In case of flexibility in design, more flexibility in design changes during the constructions, whereas limited flexibility, once components are manufactured, we can't able to change the construction designs in terms of prefabricated systems. And less waste due to the precise factory fabrications, whereas the more waste on the on-site due to cutting and errors in terms of conventional systems. While we coming across to the durability and performance, the components are manufactured to high standards, ensuring the better durability in prefabricated systems, whereas it depends on the on-site practices, variability process possibles, and suitability. It is suitable for the small customized projects and locations without transportations and restrictions in conventional systems, and best for the large scale projects are repetitive designs, example housing and offices. Whereas in terms of environmental impact, higher environmental impact due to on-site processes and transportations of raw materials, lower environmental impact due to controlled productions and optimized material used. So the process or productions of prefabricated systems will be involving manufacturing process that is on the production site, arrange the components before shipping, transportations to the construction sites, and erections on the construction sites. Next, coming across to the standardizations. Standardizations refers to the developing and implementing technical standards based on the agreed specifications. Examples: standard sizes of concrete blocks, bolt diameters, ISO quality systems. So the advantages of standardizations are interchangeability, cost reductions, quality assurance, simplified maintenance and repairs, and improved safeties. So interchangeability of the components from different manufacturers can be used together without modifications. Mass productions of the standard components lowers the productions as well as the purchasing cost, and uniform standard ensures consistency quality across the products. And standard parts simplifies the repair and maintenance operations, and adhering to the safety standards reduce the risk of the accidents. Some other advantages are it facilitates the global trade, it fosters the development and environmental benefits, effective use of materials and reduced waste due to standardized production methods in terms of the environmental benefits, whereas international standards like ISOs will be enabled to products to be accepted globally. Where the global compatibility in the international markets and simplified maintenance are the advantages of these standardizations. The factors influencing the standardizations are industry needs, technological advances, government regulations, market demand, globalizations, economic factors, and environmental considerations. The high volume industries favors the standardization for efficiencies. The new technologies may enable or require new standards. And in terms of the global regulations, legal requirements or policies may impose mandatory standards, and demand for the uniformity from the consumers and business promotes the standard adaptations, and international trade needs standardized products for the compatibility across the standards. The economic consideration, safety and reliability, availability of materials, and environmental impacts are some other the factors which has been considered in terms of eco-friendly practices, standard sizes, ensuring the consistent safety and performance levels, and cost-saving opportunities and economics of the scale-driven standardizations. Next, transportations of prefabricated structures. After factory manufacturing, the components need to be transported on the construction sites. So the methods of transportations are by road, rail, and by ships. By road, we can use flatted trucks, trailers, or specialized vehicles. By rails, suitable for heavy or long distance transports. By ships, which has been used for overseas delivery. Some specialized transport vehicles like hydraulic trailers or multi-axle platforms for oversized loads can be used in case of the transportations. Important considerations for transportation. Proper packaging and anti-corrosion protection is essential. Careful loading and unloading to prevent the damage. Compliance with the transport regulations such as size and the weight limits. Ensuring compact stability during transits, and scheduling transports to avoid the site conjunctions. So, erection of prefabricated structures. So, erections refers to the assembling prefabricated components on the construction sites to form the final structures. So, the steps involved in the erections are site preparations, which ensures the foundations and supports are ready before starting the assembly. Lifting and positioning components. Use the cranes, that is mobiles or towers, to lift the position beams, columns, panels, and slabs. Next, temporary supports. Temporary bracings is used to hold the elements in place during the assembly. Connecting components. Connections are used for bolts, welding, and fasteners and designed for the prefabrications. Ensure alignment and leveling. Precision instruments ensures the proper alignment for structural integrity. And finishing works. Joints are sealed and electrical and plumbing installs are integrated. And in conclusions, we can able to say that the production, transportation, and erections of prefabricated structures form an integrated systems that boost construction speed, quality, and sustainability. The careful planning of each steps from the manufacturing to on-site assembly is a key to successful prefabrication components. Thank you very much.